Good evening, everyone. So this is your first class with respect to your 2026 foundation. Okay. Um, my sincere suggestion here is attend the live class sincerely and gain the more knowledge. If you are having, getting some doubts or whatever, please mark the slide number. You can clarify at the end of the class also. Okay. Uh, so let me teach you from the very basics. Okay. Whatever the basics related to the chapters, surely I will cover your. Um, let's start here. The first chapter here is the number system. See, number system plays a very vital role here nowadays. So the thing here is, no, you must start to focus this chapter very sincerely, and you need to practice this chapter, no, by topic wise. By topic wise, you should not, no, study or prepare randomly. You have to go topic wise. For example, divisibility means you have to read all the concept related to the divisibility, and then you have to work out the problems and then practice problems. So likewise, remainder, you need digit, last two digit, LCM, HCF. Likewise, topic by topic you need to work on. The first thing here is, let us begin with the why number system. How number system, that I will ask you later on. Okay, so here number system, what is the purpose of number system? Before the purpose of number system, let us see some historical perspective. So if you know the historical perspective, you can able to understand why number system. Guys, you can interact, either you can put it in your chat window, or else you can unmute and you can talk also. Why number system? You can think about the historical perspective and you can give. I always prefer two-way communication. You also can give your views, whether it's wrong or right. Irrespective of that, try to interact. What is the purpose of number system? Aryabhatta zero invention. Okay, fine.
To know the differences between them, sir.
Think in the historical perspective. You guys are coming across history. No, think in that manner, not purely a mathematical manner. Why number system? Historical manner. You please, you can
So to calculate the time, sir.
calculate the time. Okay, fine. Then
People wanted to quantitatively system the things and all, sir.
okay, good. Trading purpose, good. Trade purpose, calculation purpose, quantifying things. Okay, fine. Calculate anything chronologically. Yes, good. Barter system, no, barter system differs, right? Barter system applies a number system, but it not the historical perspective of no number system. What is barter system? I am having rice, you are having something. No, yes, this much of quantity, this much of thing you are going to give. Okay, yes, that we can take. Ancient trade routes, stars, location, distance, measure the value of the things. Okay, fine. So let us do some historical perspective, and then we will move on to the purpose. So the historical thing here is, you are having, some human beings there. See, my classes will be like this only. Okay. So making you to understand something, and then only I will start. So for example, what I am going to do here is, no, I am doing some cultivation here, or else I am making, or else I am having some goats. Let us keep this guy is having a goat, or else this guy is making jewels or beads. So this guy, you can take various, or else you guys are doing some farming. So let us take some trees. So here he doesn't know the count, exact count. What actually he will do here? Some stones will be there. Some stones will be there. So in the stones, what actually the people are doing there in the historical perspective, you guys are know archaeological things, no? So they will mark like this. They will mark like this. They will mark like this. Mark like this. And no, so like that they are started this kind of things for a counting purpose, not only with respect to the trees, not only with respect to the goat or jewel or bead, whatever be, even no, in from the tree they are picking some apples, you know. So therefore, how many apples are there in the basket, how many oranges are there in the basket, so how many mangoes are there. So therefore gradually they started this kind of creation of your numbers here. So therefore this is very very important. How much are there, then how many are there, so like that, for how many bags of rices you are making. So therefore gradually they are no, involving the knowledge of numbers and operations. Okay, so this is with respect to the historical perspective. So likewise they are developing your numbers here, like natural numbers, and then natural, why natural number, then why whole number, why integer, why rational number. So therefore always you start beginning with a why. So when you are starting your preparation with a why, putting questions by yourself, then automatically you will be getting more knowledge, you'll be gaining more knowledge by placing some questions. So let us begin here with a natural number here. So natural numbers, see I'm having some tables, okay, that I will give you later, because this kind of tables you can no, go through for a purpose, no, revision purpose. So why this is a very important thing, and a few other properties also here. So therefore you will learn this kind of things elaboratively. Now the first thing here is natural numbers. Why natural number? So natural number constitute from 1, 2, 3, etc, 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 etc. So I am taking this as a infinite first of all. So infinite. So in a day-to-day life we are having this here, right? So now you can able to know that there are, or else there is a no greatest natural number. Can you say in a infinite natural number series which one will be the greatest natural number? You can't say that one. So in a infinite series you can't say which one is the greatest natural number, because you know, if you are adding one to the previous one, if you are adding one to the previous one, we are getting the next highest natural number. This next highest natural number, you can call this as a successor. You can call this as a successor. So therefore, even if you are adding 1 along with 2, you will be getting 3. So therefore 3 plus 1 you will be getting 4. So therefore you can't say which is the greatest natural number in an infinite series of a natural number. So this is also one of the important thing you need to understand. So next, see, if you want me to write in a new slide, means you please say, I will write it. So therefore you need to know about some important properties and fundamentals with respect to the natural number itself. Now here in the natural number itself you need to learn the fundamentals. So for example, let me tell you 5 plus 3 which is equal to 8. So 7 plus 11, no, which is equal to 18. So let us see 11 minus 7. So 11 minus 7, 4. Now what happens here in the case of you know 5 minus 8. So 5 minus 8 becomes a minus 3. 5 minus 8 becomes minus 3. Now try to understand here. This is a natural number. Again, a natural number. When you are doing addition, you will be getting a natural number. So therefore, in addition of two natural numbers, and see, please understand these things I am not writing elaboratively. Please make that natural numbers, no. So that is why I am addition of two natural numbers, no, again gives you a natural number. Okay. Now try to understand. It may be a, no, which one? The order may differs here. For example, a plus b or b plus a plus b or b plus a. The both the resultant will be a natural number. The resultant will be a natural number if a comma b belongs to n. Please understand, a comma b belongs to n, which means that a and b are a natural number. The resultant is also a natural number. You can take any example. Okay. Now my very important question here is, when a and b are a natural number, when you are doing a subtraction, will it be a natural number? Will it be a natural number? For example, I have provided an example also. You guys answer no. So this is also very important. The cases are here, right? Here a and b, the natural number, even you can take it up. 11 and 7 itself you can take it as an example. 11 plus 7 gives you 18, natural number. 7 minus 11, no. If you take this as an example, minus 4, this is not a natural number. So therefore, it may be a natural number, it may not be a natural number when comes to the subtraction. For example, let us take this one, 11 minus 7, so which is equal to 4. In these two cases you can take. In a subtraction, please understand, in a subtraction, no, if you are changing the order, for example, a is equal to 11, b is equal to 7. If you are changing the order, what will happen? If you are changing the order in the subtraction, it may or may not be a natural number. May or may not be a natural number. So please understand with respect to the subtraction. So that is why I am erasing this one. Now you understood that is why I am erasing this one. In a subtraction, it may or may not be a natural number. So first thing you need to take this one. Okay. Now let us start here with the multiplication here. So you can take a multiplication. 4 into 3, which is equal to 12. Again a natural number. Okay, n and o means a natural number. Now 3 into 4, again a natural number. That is why you can say that a multiplication is a commutative in general. Multiplication is a commutative in general. Multiplication of any two natural numbers. Multiplication of any two natural numbers are commutative. So fundamental is very important. That is why I am teaching you these things. Now, next here, let us take a division. So when you are taking a division, what will happen here? For example, 6 by 2. 6 by 2 is equal to 3, natural number. So what will happen? 2 by 6, 1 by 3, 1 by 3. Right? So therefore, it may or may not. It may or may not. Okay. May be a natural number, may not be a natural number. So therefore, what can be derived here? In a plus and multiplication, the resultant will be a natural number. In a subtraction and a division, it may or may not be a natural number. Guys, understood up to this? Okay, fine. Next here, representation of a natural number in a line. So let us see that a representation of a natural number in a straight line. So how to do that representation? Let us take this as a representation. Guys, I will teach you very slowly only. 10 minutes or 15 minutes. No, saving your 10 minutes or 15 minutes. Those are watching recording. Fine, up to you. 1, 2, 3, 4, 5, 6, etc., etc., etc. So therefore, representation here. Okay. Next, let us move on to the whole number. Now, so let me teach you whole number in depth. First of all, try to understand why whole number. That is also important. Why whole number? Now try to understand what will happen when same two natural numbers are subtracted. Please understand. Why? When same two natural numbers are subtracted. What will happen? 0. What will happen? You will be getting a 0. Okay. So for example, 1 minus 1, 0. 2 minus 2, 0. 3 minus 3, 0. It keep on moves. That is why the 0 is included here in the whole number. Okay. The natural number extended here with the number 0. You will be getting a whole number. Can you say which one is the greatest whole number? Surely not. So therefore, there is no greatest whole number in an infinite whole number in an infinite series of, or else infinite sequence of. Let us take infinite sequence instead of series. Let us take an infinite sequence. That is better. Infinite sequence of whole number. So now let us start here with some properties or whatever the condition. What happens with respect to the 0? What happens with respect to 0? Now please understand. Any number is added with a 0, you will be getting that number only. So therefore, this applies here with respect to addition. So whereas will it apply with respect to the subtraction? Exactly no. A minus 0, which is equal to A, but 0 minus A is not equal to A. So therefore, not defined in whole number. That is why 3 minus 0 becomes a 3, but a 0 minus 3 becomes a minus 3. Whether minus 3 present in the whole number? No. So therefore, from this itself you can able to know that the extension of that whole number becomes the integer. Extension of a whole number becomes an integer. Now, before moving to the integer, focus on this one. Please mute. Don't disturb. Please mute. Now, try to understand. When a into 0 becomes a 0, which means that any number is multiplied with 0, you will be getting 0 as the resultant. Vice versa. The reverse is also a true. Now try to understand with respect to the division. The division plays a very crucial role. When 0 by anything, please understand, 0 by anything. 0 by anything which is equal to 0. Then anything by 0 is equal to not defined. Anything by 0 is equal to not defined. You can take any number. As an example, 0 by anything. 1, 2, 0 by 1, 0 by 2, 0 only. Now, 1 by 0, 2 by 0, not defined. So now you can represent here. So therefore here you take it as a 0. Here 1, here 2, here 3. So like that it move on. So this now let me erase that left side here, no added arrow, because it moves here in this direction only, not in the left of the 0, only the right of the 0. Okay. Next, now you can able to understand why we are getting an integer, because 3 minus 0 is equal to 3, 0 minus 3 is equal to minus 3, which is not defined in the integer as well as not defined in the whole number. So therefore we are moving here with respect to the integers. So now you understood why integers, right? Just now I explained why integers. So therefore integer, for example 1 plus 1 plus of minus 1, which becomes a 0. Then you can take a 2 minus 3 is equal to minus 1. So therefore if 0 is there, the left of the zeros, nothing but it defines the negative. Minus 1, minus 2, minus 3, minus 4, etc. The right of the 0, nothing but 1, 2, 3, 4, 5, etc, etc, etc. I am giving etc, etc here. So therefore the integer contains 0 as well as that left of the zeros are negative, right of the zeros are positive. And one more basic detail you need to know here, that simple detail, because you guys know that the UPSC now giving in terms of A, B, C, D, E, P, Q, R, S, like that, right? When the questions are coming in that format A, B, C, D, or see, if the questions are in the format of numbers 1, 2, 3, 4, easily you guys are able to solve that question. When the questions are in the format of A, B, C, D, or else P, Q, or else the people are feeling difficult to decode such a questions. So therefore apply those things and decode those things, decode the questions and work on. For example, let us take this as a let us take this as a let us take this as a B, let us take this as a C, let us take this as a D, let us take this as a E. See, in a sequence I am taking your A, B, C, D. Now my simple question here is whether minus 2 is greater than minus 4 or else lesser than the minus 4. Guys, answer. Is minus 2 greater than minus 4 or minus 2 lesser than minus 4? Greater. So minus 2 is greater than minus 4. So guys, okay. Now you guys are clear. Okay, fine. Okay, good. Fine. So therefore this is correct. Minus 2 is greater than minus 4. In generally, let me give you in general. In general, let us take two numbers. Take two numbers, that is A and B. Let us take two numbers, that is A and B. First condition, A greater than B, A greater than B if A is to the right of B. Now try to understand now. -2 here. So let us apply here. This is nothing but a A. This is nothing but a B. Now you can see here clearly. A is the right of B. A is right of B. Because you are going to compare which is greater, which is lesser. -2 and -4 only we are taking. So therefore, when the A is the right of the B, then you can say that A is the greater than B. Now the second point. A is lesser than B. Lesser than means what? If A is to the left of B, A is to the left of B, right? So this is also you can take. Lesser than means. So now, or else, can you decode in another way? If B is, see, instead of A is, you can decode in this manner. If you are changing this one, that is better. If B is to the left of A, can we write in this manner? That would be better. Guys, understood up to this? Check that one. Guys, check that one. Which is better? Absolutely no. That is why you need to be very careful. Okay, be careful in this kind of things. If A is to the left of the B, then A is lesser than B. So therefore, in generally, you have to work on, okay, very clearly. So now, can we say a natural number is a whole number? A whole number is a integer. Up to this, you guys understood? Okay, fine. Now, so from all the three discussions, you can able to note few more things. All natural numbers are whole numbers as well as integer, because based on the diagram, right? So as well as integers also. But whether reverse is true? No. But the reverse is not true. Please understand, reverse is not true. Next point. All whole numbers are integers. All whole numbers are integers. Whether reverse is true? This reverse is true. All the whole numbers are integers. All integers are whole numbers. No. Fine. Okay, good. You guys are okay with the basics now. So now, gradually, we will move on to the rational number. Why rational number important? Guys, we are done with the natural numbers, right? We are done with the natural number. In a simple manner, I have provided here. The natural number means all the counting numbers from starting we are with the 1 to the infinity. Whole numbers also we are done. Natural numbers plus 0. Integers, the whole number includes negative and positive along with the 0. Next here, even and odd number. Whatever a multiple of 2 here is nothing but the even number. The rest going to be the odd number, which means not a multiple. Not a multiple of 2. Not a multiple of 2. So therefore, a whole number which is divisible by 2 is also a even, right? Which does not divisible by 2 or odd. So or else multiple of 2 you can take it as a even, rest not a multiple, that also you can take it as a odd number. Next, the prime number concept I will teach you elaboratively tomorrow. Okay, this prime number concept, co-prime, twin prime, these things I will elaboratively teach you tomorrow, because you guys are able to see that at least I always used to say in every examination with respect to the CSAT, at least one of the applications of the prime number question will be there. 100% will be there. So therefore you must have to be careful with the prime number concept and develop all the properties related to the prime numbers and work on. Here in the 2025 also there was a question related to the prime numbers. Even 2024 also. Every year you will be getting. So therefore for 2026 you have to prepare accordingly. Okay, fine. So now we are focusing on the rational number and irrational number. Let me elaboratively discuss these things and then I will come back to here. Now try to understand why rational number. See, why always important? Put a question by yourself. So let us take some situations. Six by 2. What happens here? 6 by 2. Automatically you will be getting 3. Or else can we say 2 into 3 is equal to 6? Yes. So which means can we discuss this as a when a by b is equal to m. When a by b is equal to m implies a is equal to m into b, where a is equal to m into b, and also the m is also a natural number or integer. M is also a natural number or integer. Why I am stressing on integer means because the rational number can be in the format of negative also, that I will discuss elaboratively. Now try to understand. When it is in this format, no, this is a 100% okay. Now what happens in this format when a is not a multiple of b? When a is not a multiple of b, for example, here this 6 is the multiple of 2. Multiple of 2. Now let us take a 7 by 2. This 7 is not a multiple of 2 table, right? So in this case you are not getting an integer as the resultant, whereas in this case you will be getting an integer as a resultant. You will be getting integer as a resultant, whereas this is not an integer, which is not an integer. So therefore when a situation arises like this, you will be forming a rational number. You will be forming a rational number. So this is a new type of a number. This new type of a number is called as a rational number. This rational number, is it in the form of, or else is in the form of, instead of is it? Okay, fine. Let me explain instead of raising a question. Yes. Is it in the form of p by q? Means yes. Surely it is in the form of p by q. And a very important note, I will give you the definition later on. So you please take these simple things. Where p and q are integers, also q not equal to 0, then you can call these as a rational number. then you can call this as a rational number. So example I'll give you. Sir, I'm using as a integer, sir. So when I'm using as a integer, negative also can be expressed in terms of a rational number. Please understand that also. That negative one can be expressed here. For example, can we say already we have mentioned here 6 by 2, here 7 by 2, right? Fine. Can we say minus 2 by 3? Yes, this is also a rational number, right? So that is why I'm going to elaborate this rational number here. So therefore, this rational number I am taking as a positive and negative here. Positive and negative. So positive means what happens here? Both P and Q must be positive. Must be a positive. Whether is it the only case? No. Both P and Q must be a negative. Must be negative. Please understand. Both the things are applies here in order to get the positive. For example, 2 by 3 minus 2 by minus 3. So therefore you will be getting your 2 by 3. So that is a positive rational number. So which means that the numerator and the denominator both must be a positive, or else the both numerator and denominator must be a negative. Then you will be getting a positive rational number. Then you will be getting a positive rational number. So now let us focus on the negative rational number. Sir, what are the situations, sir, with respect to the, because it is in the format of P by Q. So the situation can be minus P by Q, right? The situation can be no P by minus Q. So here this format is also here no negative. Both the format you can take it as a negative here. For example, minus 1 by 2 or else 7 by minus 2. Both the cases it forms a negative rational number. So therefore, what are the forms of a rational number? Forms of a rational number. One here is P by Q minus P by minus Q minus P by Q, P by minus Q. So these are the forms of your rational number. Rational number. So now let me give you a definition of your rational number. See, revise the handout, revise the class PDF, more than sufficient. Okay, I am giving elaboratively. A rational number P by Q where P and Q are integers, comma Q not equal to 0, where Q is positive or made positive, and also P and Q are coprime. What is the concept of coprime? Coprime means their HCF must be a 1. See, always the people are focusing when the HCF are 1, then they are coprime. Even when the HCF is minus 1, then also a coprime. Please understand that one. Okay, which means that the common factor. So if you want, you can take it in let me write it in another color. Guys, facing any issues means you can take. So therefore here, which means they do not have common factor other than 1 or minus 1, other than 1 or minus 1, or the HCF must be a 1. HCF is equal to 1. Okay. So therefore, this is with respect to the rational number. With respect to the rational number. And a few more important things are there related to the rational number. So with rational number and irrational number, let me complete the class today. Still 20 to 30 minutes class will be there. So therefore here I am going to discuss some properties of rational number. Properties, or you can take it as a PTR. So always gives a PTR. PTR means points to remember. Points to remember. Number 1. Every natural number is a rational number. Please understand, every natural number is a rational number. Whether the reverse is true? No. But the reverse is not true. The reverse is not always true. Not always true. This is a very important point. For example, you can take 1 can be a rational number. 2 can be a rational number because the denominator here 1. But the 1 by 2 remains a rational number, but it is not a natural number. 1 by 2 remains a rational number, but not a natural number. So therefore, be careful in that things. The properties plays a very vital role. So 2 by 1 belongs to a n. 1 by 2 not belongs to a n, but belongs to a r. This one belongs to a n as well as belongs to a what? Q. Q means a rational number. Okay. Don't take it as a r. R here is nothing but the real, full real. Q here is nothing but the rational. Now, second property. Every whole number and integer. Every whole number and integer is a rational number. But reverse is not always true. Reverse is not always true. So please take this kind of things in your notes. Guys, everyone understood up to this? Understood up to this means let me proceed with some other points. Okay.
Sir, can you please repeat the first point, sir? 2 by 1 belongs to natural,
then rational number. Because 2 by 1 nothing but it is in the format of P by Q. Understood?
Okay. So Q meaning is what is the
Q is the denominator.
okay.
Understood, Appa? Kamalesh. Okay. See, those who are joining for the classes, try to attend the class completely. Maybe the 1 hour, right? If the students are going begin the recordings, please watch the recordings completely. Don't waste your time. 30 minutes joining, then leaving, wasting your time. So these things don't do. Okay. Completing means complete on the same day. That's it. Either live or recording, complete on the same day. So that is my simple suggestion. If you are keeping it as a backlog and watching at the end of the 3 months before the prelims means, surely you will feel a pressure. So don't do such a mistake. So now let us move on to the some more important things here. So now let me tell you the equivalent form. Guys, this is important because in a ratio and proportion also you people are using this here. Always. The equivalent forms of a rational number. the equivalent forms of a rational number. For example, 2 by 3, let us take 2 by 3. This can be written as a by b. So in a ratio, what you guys are writing? A is to b, which is equal to 2 by 3. So this you can call it as a fraction. But, right, okay. In fraction, that is entirely different, because there are a proper fraction, improper fraction, mixed fraction. So that is why let me teach you fractions elaborately in the upcoming days. Now focus only on the rational number. Rational number means numerator by denominator. That's it. So that alone you need to focus here. Whether, yes, 2 by 3. What is the equivalent form? Can we write this as a 4 by 6? Yes. If you cancel this one, you will be getting 2 by 3 again. Right. So therefore, 2 by 3 equivalent to 4 by 6. Please understand. Anything? 2 by 3 is equivalent to 2 by 3 is equivalent to 8 by 12. Yes. Next one. Can we write your 16 by that? No. 16 by 24 is correct. 16 by 24. 8 table, if you are cancelling, then you will be getting. So therefore, that equivalent format also you need to understand here. Okay. Because UPSC may give anything. Which of the following? They will be, no? They will give you 4 options like this. Which of the following is not correct? Which of the following is not correct or correct? So they will put a question like this. For example, they will give you A, B, C, D. Please understand now. Okay. So they will give you, so like this, no? They will give you which of the following is correct or not correct. See, whatever you can work on like this. So they will give you some equivalent of forms here. 5 A, B, C, D. Okay. So let me take A, B, C, D here. So they will be giving some, no, A, B, C, D, E here in all the options, sir. Then they will ask you to choose which of the following is the correct. Yes, that also one question. There is a possibility which of the following is not correct. So therefore you have to check here whether it is in the equivalent form, whether it is in the prime format, which is not in a prime format. So like your questions will be there. So you have to be very careful. That is why I am teaching you this kind of equivalent forms of the rational number also. Right. Next. I do not want to give like school students things, right? Yeah, 5 rational number or 7 rational number. These things I am not going to give. You have to identify. Okay. For that, just you need to know about the procedure. Okay. Next here, comparison very important. Since this comparison of a rational number or else in another way, listen, let me tell you one thing. This comparison of the rational number can be in the format of questions. Okay, let me tell you the questions here. Possible questions here. Arrange the following fractions. Please understand fractions. I'm using the fractions. Why I'm using the fractions, I will tell you later. Arrange the following fractions in ascending order, in ascending order, or increasing order, or descending order. Descending. See, don't bother about the spelling mistakes. Okay, understand the concept. Descending order or decreasing order. Okay, so that is a possible to get a question like this. decreasing order, increasing order. So this is the question possible with respect to the fractions, right? Sir, you are teaching a rational number, why involving the fraction, right? Let me tell you why involving the fractions also here. So what is the major difference between the rational number and no fraction? In a fraction, it is in the format of p by q, that's it. Whether the numerator is greater than the denominator or else lesser than the denominator, these things and all you should not bother in the rational number, whereas in the fractions we have to bother those things. Okay, so that is the main difference, nothing else. So now let us focus on the rational number. Focus on the rational number. So now try to understand.
So can you repeat what is the difference between fraction and rational number? I didn't get it.
A rational number, it is in the format of p by q. A fraction, no. Okay, okay guys, wait a minute, let me explain the fraction first and then we'll move on. So now fractions. Split as a 3. Fraction means numerator to the denominator format. Now here in the fraction you are having proper fraction, improper fraction, mixed fraction. Okay, in a proper fraction, a numerator is lesser than the denominator. For example, 9 by 11. Improper fraction, a numerator is greater than the denominator. 11 by 9. 11 by 9. So this is the fraction here. So whereas a proper fraction means a numerator lesser than the denominator. Improper fraction means numerator greater. Both the cases are rational numbers. Both are rational numbers. Yes or no?
Yes, sir.
Both are rational numbers. Understood? Soumyava. Okay. Both are rational
Yes, sir.
numbers. Okay. Now try to understand. Now this improper fraction can be converted in terms of a mixed fraction. Please understand. This improper fraction can be converted into a mixed fraction. 11 by 9. 1 time. 9. 2. So how can you write this one? So that plays a vital role. How can you write this one? Guys, here, then. So let me give you option. You guys tell which are the options are correct.
Yes.
A, B, C, D, E. Okay, A. Right. So therefore, please understand the formats are very important. People may get a confusion in the format, mixed fraction format. Please understand these and all not a format. Okay. So see, I am erasing these things. So those who are watching the recording or else attending the live class, they only can able to understand this ABCD option. In your handout, just this only present. Okay. That is the importance of attending the live class or else the recordings completely. So now try to understand. So this is nothing but you have to multiply this here. 9 into 1, 9. 9 plus 2. So therefore 11 by 9. So now how can you write this here? Quotient, please understand. Quotient, remainder, by divisor, quotient remainder by divisor. You guys know division algorithm, right? I will teach you division algorithm later on. Since it is focusing on the rational number, I'm just focusing on rational number. Divisor into quotient plus remainder. Please take in this format. That's it. Divisor into quotient plus remainder. Divisible by remainder. Sorry. Divisible by divisor. Or else you can keep it in the simplest format. That's it. So this is nothing but the mixed fraction. Guys, understanding? Shall I move on to the next? No.
Yes,
Let
sir.
us do this here. Let us do this here. So now try to understand. If the questions are a comparison based, in a fraction I will teach you that are ascending order, descending order, etc. Just one simple thing I'll give you. For example, 5 by 11 and 5 by 17 and 9 by 17. If I'm giving you here and asking which is greatest, that there is a possible to get a question on this separate topic. I will teach you ascending order, descending order separately. I'm just giving you here for a better understanding. So here which is greater here means in a fraction we used to say that as a like fraction. Like fraction means same denominator. Like fraction means same denominator. So now you are focusing on the rational number. If same denominator, in a simple manner I give you same denominator. If same denominator, then the greatest numerator is the greatest. Greatest numerator is the greatest. That's it. So now, therefore, what will be the answer? 9 by 17 is greater than the 5 by 17. Guys, understood? By taking this one. Which is the smallest means we can apply the same here. 5 by 17 is smaller than the 9 by 17. Guys, understood the comparison of these things? Fine. What would happen? Listen. What would happen if the different denominator? If different denominator. Convert into the same denominator. Simple. 5 by 11 and 9 by 7. If I am giving you in this format, then what you need to do? You have to take the LCM between these two. What is the LCM between these two? 77. So multiply here into 7, 7. So 77, 35. 9 by 7 into, we have to get a 77. So 11, 11. So therefore 99 by 77. Now can you able to identify which is smallest here? Guys, which is smallest here? Both the denominator are same now. Smallest 35. So therefore 35 by 77 smallest than the 99 by 77. Your answer will not be in this format. Your answer will be in the question format. What is the question here? 35 by 77, which is equivalent to what? 5 by 11. So therefore 5 by 11 here is smallest than the 9 by 7. You guys able to understand up to this? Okay, fine. The last topic. So before going to the last year, let me tell you the decimal format, because if I gradually go to the decimal format, then only you can able to understand why we are using irrational, why we are using non-terminating, terminating, that kind of concept, recurring decimal concept. In 2020 there was a question based on a recurring decimal. So therefore you have to be very careful here with the decimal also. Decimal representation of a rational number. decimal representation of a rational number. For example, I'm giving 12 by 5. When I'm giving 12 by 5, what you guys are doing? So 12 divisible by 5, school method. 2 times 10, 2 smaller than the divisor, therefore 1.0. So therefore 4, 5 into 4, 20, 0. So therefore 12 by 5, which is equal to 2.4, which is equal to 2.4. That's it. Now, can we say this as a terminating? Yes, this you can say as a terminating decimal. This is nothing but the terminating decimal. So for the better understanding of a terminating decimal and non-terminating, that is why I am giving you this as an example. Now let me give you non-terminating example. 7, let us take a 7 here, 3 here. So therefore 2 times 6, 1.039, 1, again a 0, therefore 3, again a 1, again a 3. So therefore 1, it keep on going. So therefore this 2.3333 etc etc, this etc 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 etc, no, this is nothing but, please understand, after a decimal point, please understand the word, after a decimal point, all the digits are getting recurring. All the digits, okay, recurring I will teach you separately. You just understand the non-terminating. So this is nothing but the non-terminating. Guys, understood the difference between terminating decimal and non-terminating decimal? Okay, fine. So can we write this as a 2.3 bar? What do you mean by the bar? So the bar over the digit, or else the group of the digit, which means that it is repeating itself indefinitely. The bar defines it is repeating indefinitely. Please understand, indefinitely. So that word also very important. So now based on that, guys, wait a minute. Okay, so now guys, give me 1 minute. So now you, based on that, let us create some conclusions here. See, the conclusions very important, or points to remember very important. So therefore decimal representation of a rational number, decimal representation of a rational number is, number 1, either terminating a decimal, number 2, or non-terminating decimal. Listen carefully, decimal representation of a rational number, okay, non-terminating decimal, Now let us move on to the another format. Please understand. Suppose, guys, suppose part also very important. You guys know this one. So 0.48. How can you convert this decimal into a rational? 2, no, after the decimal point 2 places, no, then you have to multiply with 100. So therefore 48 by 100. Simplest form, please understand, simplest form, nothing but the rational form. What would be the simplest form? 12 by 25. This is nothing but the simplest form. So the simplest form here is nothing but the rational number. Even it is not, even 48 by 100 is also a rational number only. but always try to reduce into a simplest form. Okay, always try to reduce in terms of a simplest form. So now this is nothing but the rational number. So now, so another 6 to 7 minutes, please understand, this is a very important concept. See, don't ever bother about the people who are joining and leaving. Okay, I will take a class and the students are joining and 40 are leaving, no problem. 60 are there or 40 are there also, I will take a class. Even 10 also there means I will take a class. But don't worry about that. Attend the class sincerely. Very important. Now try to understand. This model was there in the 2020. So I'll give you. Now 0.6666 etc etc. Actually, let me teach you the procedural method here in a concept called as recurring decimal into a fraction. There I will give you a shortcut. Here learn the procedure. So what you need to do here is you have to take this as a x. Then that single digit only getting record. That is single digit means 6 only getting record. So therefore what you need to do here is you have to multiply by 10 on both sides. You have to multiply 10 on both sides. Keep this as equation number 1. Keep this as equation number 2. You have to subtract 2 minus 1. What will happen when you are doing 2 minus 1? This is nothing but a 9x by 9x. Directly you can write. So therefore you will be getting 6. So therefore x is equal to 6 by 9. Or simplest form, x is equal to 2 by 3. Actually, this is the proper procedural method in order to convert recurring decimal into a fraction. But this method is a lengthy method when it comes to the more than 2 digits getting recurring, more than 3 digit getting recurring. More than 2 digit getting recurring means it's so complicated. 1 digit recurring here means you have to multiply here with a 10. 2 digit means you have to multiply here with a 100. 3 digit means you have to multiply here with a 1000. So the complicated, which means for example I'll give you. For an example 0.374374374374. Now try to understand that a 3 digit getting recurring after the decimal point here. So then how many values moves here? Please understand. So this is nothing but let us take x 3 places. No, you have to multiply here with a 1000. So therefore 374 point. It keep on moves 374, 374, etc. etc. Keep this as a equation number 1. Keep this as a equation number 2. 2 minus 1. So therefore 999x, which is equal to 374. So x becomes a 374 by 999. So this is the format. Procedural method to convert recurring decimal into a fraction. But I will teach you the shortcut method when it comes to that kind of questions. Now, next year, last point I'll discuss here itself in the table itself. Guys, we are reaching the last one. Rational number completed. Any number which can be expressed in the form of p by q elaborately discussed. Irrational number. So irrational number, you guys learned non-terminating decimal. So now non-recurring decimal. So that only you need to understand. Non-recurring means, first of all understand the recurring decimal and then you can move on with the non-recurring. Recurring means you guys have learned here 0.3333 etc etc, which is nothing but 0.3 bar. So this is recurring. Now the non-recurring means 0.3456 etc. So this is non-recurring. Non-terminating means it keep on moving here. The 3 dots, no, that 3 dots here is nothing but the non-terminating. It satisfies both non-recurring as well as non-terminating. Satisfies non-recurring and non-terminating. then you can call that as a irrational number. So you can say, no, example for irrational number. So the irrational number examples you can take the root 2, root 5, root 7. So these and all examples for a irrational number, which means that irrational number means that the inadequacy of a rational number, inadequacy of a rational number. So then you can call that as a irrational number. Okay, so now we are reaching, no, at the last minute of this class. Now the time is open for your doubts. If anybody having a doubt, you may ask. If there is a no doubt, we will meet again by tomorrow same time. Thank you all. Have a good day.